Hi everyone, I'm Hamid Reza Jahangir, research fellow from University of Warwick. I'm here to present our Spring project. In this project, I work with Dr. Subhash Lakshminarayana and Professor Karsten Nagel, the PI and co-PI of this project. Our Spring investigates the security analysis of impending cyber threats by high-voltage IoT-enabled devices on the power grid. These devices can be defined as a smart charging point of electric vehicle, air conditioners, and so on. Although these devices provide convenience for the end users, they can be defined as a convenient entry point for adversary entities to intrude into the power grid security and disturb the operation and security of the power grid. These kind of attacks are known as botnet attacks, where the attackers try to breach into the security of these high voltage devices and gain their control and then manipulate the power grid load demand. As the stability of the power grid relies on the balance between the generation and load demand, by manipulating the power grid load demand with these high voltage devices, the attacker can upset these balances and provide serious concerns for the power grid operator. Regarding the feasibility of these kind of attacks, we should talk about two main concepts. The first one is about the number of high voltage IoT-enabled devices in the power grid. For instance, we can talk about electric vehicles. As we know, the share of electric vehicles is increasing day by day, and it has been intensified these days due to the crisis of the fuel costs. And we see more people are going to buy electric vehicles rather than before. And in UK, we have more than 400,000 charging points, and it has been mandated that newly installed charging points to have a smart functionality, so they can send and receive information and respond to this information in real time. The second aspect is about the security of these devices. As all of these devices are manufactured by different third-party vendors, there is no integrated security protocols for these devices. And improving their security protocols will affect their final cost. In PowerSprint, we have two main objectives. The first one is about to investigate the security analysis of these kind of attackers on the power grid and try to find the most vulnerable part of the power grid and secure the power grid against these kind of attacks. And the second objective is about to design a data-driven techniques to detect and localize these kind of attack with high precision. In this project, we have two partners. The first one is Schneider Electric that give us testbed to verify our developed idea in real case studies. And the second one is Global Cyber Alliance that give us information about how often these kind of attacks happen and a brief description about the attacker strategies. By now, we have two publications for this project that discuss the risk analysis and also proposes a data-driven techniques for detect these kind of attackers based on regression work. In our recent work that is shown here, we have developed a data-driven technique based on image processing IP. As we can see here, we turn our power grid data that consists of frequency and voltage of the power grid into an image structure and design this image processing technique to detect and localize this kind of attack with high precision. By now, we reach about 94% accuracy in our simulation. We also consider noisy data, outlier point, and missing point in our simulation, and this framework presents robust performance in this situation. In our future work, we are going to implement this idea in real case scenarios, and also we are going to improve our feature extraction task with modern AI-based techniques. If you are interested in this project, you can talk to me in this conference. Thanks for your time and also.